Hello, guys. Welcome back to Maths on African Motives. Okay, this one is August 2023 exam. All right, and that's still on the. We still want to get the concept of our moments. All right, the volume moment, and also the center of gravity. All right, so it is a similar question to the previous one that we had in terms of the axis of rotation. So I just want to make a clarity on that part, all right? So that we all understand for exam purposes, all right? They are saying on 5.31, we are supposed to make a neat sketch of the graph of y is equal to e to the exponent of minus x. Like I said, the drawing or the sketching of the graph, this one, you're supposed to be now up to standard to know each and every function, right, from your N form. So anyways, we're going to have this. Remember, the exponential function, we expect it to be of this way when it is positive. Y is equal to a to the exponent of x, where this is a positive, right? Or we can have y is equal to a to the exponent of minus, where it is a negative. We expect our graph to be like this, tending to be approaching to zero. When it is a negative here, it's a reflection that will happen in the x-axis. And also this one, it will be a reflection again in the y-axis, just something like this. But there we are given, it is not having a positive, it is having a negative exponent, not here, the number here, but the exponent is the one that is a negative. So we expect our exponential function to be that way. So this can be for any graph. That's why I'm using y is equal to a to the exponent of x, or y is equal to a to the exponent of minus x. Meaning to say, next time, they might not give you as e, they might give you as 2. Y is equal to 2 to the exponent of minus x, or y is equal to 3 to the exponent of x. It follows suits the same way, the same shape and everything. This is what you just need to understand, all right? So this is your x-axis, your y-axis, and at a point where x is equal to 0, at that point, y will be equal to 1. So it crosses a value of y at 1. All right, so that is how we expect our function to be like, going that way. So there we are given that we are supposed to show the representative strip or element that you will use. It's your choice, this one. All right? We are not given it's parallel, it's perpendicular, it's your choice. But it's supposed to be of the volume generated if the area bounded by the graph, the lines x is equal to 1. So there's a line x is equal to 1, maybe somewhere here, we've got a 1 there. So we've got the line x is equal to 1. X is equal to 0. X is equal to 0 is what? Is our y-axis. So we are bounded by the x is equal to 0. Y is equal to 0, which is what? Which is our x-axis. So meaning to say the area that we're talking about is here. This is the area bounded between the x-axis, between the line of y-axis and the line of x is equal to 1. This is where our area is bounded there. So the representative strip, it's of your choice, all right? This one, it's of your choice. This one, it's of your choice. You're going to have it, whether, guys, this one, yes, they are saying that the area that you're gonna, the volume that you're gonna talk about, it's of the area that's gonna rotate about the y-axis. This one is for the rotation, it's for the volume. When you are calculating the volume, meaning to say, here they're asking now for you to calculate the volume. Yes, it is the volume that you are calculating with respect to y. But as for the limits and what we have, and in terms of the integrals here, we can have our representative strip in the x, all right? It is easier for us to work one with the integral of an exponential than for us to introduce, because if you make this the subject and work with x, you're going to work with a logarithm, of which is fine. But you work with a logarithm there, and it's difficult now for you to be having those logarithms in your integrals. So to avoid that, it's easier for us to integrate e. So you're going to use the representative strip in the what? In the x, so that we use y is equal to e to the exponent of x, because the representative strip is for what? It's for x, and the limits there will be for what? Will be for x. So that is what we can have on that part. So like I said, the representative strip is not controlled by this to say it rotates about the y-axis. No, it's not about that. The y-axis, the rotation, it affects what is rotating, the volume generated. So now they're asking you on 5.32 to calculate that volume, which we talked about here, to say this volume, it rotates about the y-axis. So it's Vy. All right. So now, in order for you to have the volume, there are two ways, because it's either it is going to be shell or the disk method. So we have to check now. This is volume with respect to y. But the representative strip that we are using, so that we use the limits for x in this case, is for x. The volume is for y. The representative strip is for x. So it's a volume with respect to x. Volume of y with respect to x. Does this part make sense? No, it does not make. Whenever that condition happens, you know that you're going to apply the shell method. All right, this one is going to be your shell method. If it was the volume with respect to y and your representative strip is with respect to y, these two, they are corresponding to each other, you apply the disk method, all right? Or you can use the concept of being parallel. The shell method, you use it when the representative strip in this case is parallel to the axis of rotation, Our axis of rotation here is the y-axis. This is our axis of rotation. This is our representative strip, which is our representative strip is like this. This is our representative strip like this with respect to x. Then the axis of rotation is the y-axis. We are talking about the y-axis. So you're saying the axis of rotation, which is our y-axis, and the representative strip, in this case, these two, they are parallel to each other. They do not meet. So when it is parallel to each other, you apply the shell method. But on a condition that maybe your representative strip is this one, then the axis of rotation, they asked you to calculate the volume about the x-axis, meaning to say they are perpendicular to each other. You use the disk method. Here, you apply the shell. Or you just apply that idea that I was talking about to say, if these two, they are not corresponding, to say this is y, this is x, you use what? The shell method. All right, which one is the shell method? All right, if we check here, on from our formula sheet, we've got these volumes that I explained before. So here is where we have the volumes. These volumes here that we have are the for the shell method, where the volume with respect to x is found with a derivative with an integral with respect to y, not x. Y opposes x, that is for shell. If x goes with x, that is the disk method, the one that we're doing in what? In N5. These were the formulas that we're working with in N5. So this one is an advantage that we at least talk about the shell method in our N6, because this is what we have, this introduction that x does not correspond to y. Then you wonder, why is that so? I'm calculating the volume for x, but the strip is for y, because in N5, it was direct, it was the disk method, Vx, dx, Vy, dy. But here it opposes. Once it opposes that, it's a shell. All right, so this is what we are going to have. So we saw that the volume with respect to y from the shell method is given as 2 pi, the integral of a and b, that was given as xy like this with respect to x. I'm going to explain this. What does it mean? So this x, right, it's for we are talking about the x values, like it is the strip that we are talking about is for x. So we use x for that. The strip for y, we use y. Then this y is for the function, our f of x. What is our f of x? This y is for f of x. So there is no substitute for this x, but there is a substitute for y, which is our f of x. Y is equal to the function of x that we are given as e to the exponent of what? Minus x. So meaning to say, we can be able to calculate our volume. So the volume with respect to y is going to be 2 pi, the integral of the limits in x dx. The limits are for x from 0 to 1. So that's from 0 to 1 times x. Then y, I said it's a function of x that we are given. And this is the function of x, which is e to the exponent of what? E to the exponent of minus x with respect to x. All right. So this is what we have as our volume. So as you can see, guys, it's a volume of y, but the integral is with respect to that. This does not make sense. So that is the shell method part. All right. Whatever happens here, you've substituted, you have your formula, you've substituted, whatever that is happening here, it's up to you. How are you going to integrate that? Which part are we going to apply? So this is it by parts. We've got a product of an algebraic and an exponential function. So there we can integrate this by using by parts method. Remember, by parts method states that if we are to integrate with respect to x, the integral of f of x, all right, let me just use something here. The integral of f of x g prime x dx, we have this formula in our formula sheet, is equal to f of x gx minus the integral of f prime gx dx, like this. All right. So meaning to say we're going to need our f of x, which is the easier part to use. That is for x in this case. All right. Remember that was x, not e. This is x e to the exponent of minus x with respect to x. All right. So I'm going to choose my f of x to be an x e, which is I mean this x, which is easier because if we choose this, yes, we're gonna have this, but if we choose this now to be a part that you integrate, you're not going to finish your, because you integrate x, it will be x squared over 2, you integrate x cubed over, so it is keeping on increasing. So to avoid that, choose your f of x to be what? X. So our f of x is x. And I also talked about this on our by parts, that when you're talking about, when you are given an algebraic and an exponential, it's best that f of x is what? An algebraic. So that means you're going to need the first derivative with respect to x, which is a 1. All right. Remember, from our by parts here, we're going to need the remaining part, which is g prime x. All right, so this is g prime x dx, which is equivalent to what? E to the exponent of minus x dx. That is this part here that is remaining. So you integrate both sides so that you obtain gx. The integral of e is e to the exponent of f of x over the derivative of that function. So the derivative here is going to be -1. So that's e to the exponent of -x. We're going to even multiply by a negative here, because over -1, guys, is going to be minus x here, so it will be minus e to the exponent of -x. So this is what we are going to have. Remember what we are integrating. We are integrating this. We want the answer here, so we just do the integrals aside, all right? So from this, we are going to find our integral. So therefore, the integral here is going to be equal to f of x by gx, whereby f of x is x by gx, which is our gx, we got it here. That's minus e to the exponent of minus x minus the integral of f prime x, which is 1. So there we got 1 times gx, where we got negative e to the exponent of minus x dx. So remember, on your by parts, you are supposed to finish again integrating, combine this, that will be minus x e to the exponent of minus x minus and minus, that will be a plus. So we will be having plus the integral of e to the exponent of x with respect to x. So we have to integrate this. We are given, we still have the integral sign from our by parts formula. It consists of that integral sign, but we integrated e to the exponent of minus x before here. So it's not something that you're supposed to redo again. We're just taking the answer. So that will be minus x e to the exponent of minus x plus, remember the integral of e to the exponent of minus x, it gave us what? It gave us minus e to the exponent of minus x. So this is what we have, minus x e to the exponent of minus x plus minus, that's minus e to the exponent of minus x, like this. All right. So I want us to be clear here. I want us to be clear. This here, what is that? We are integrating this x e to the exponent of minus x. So what we need here is the answer only. So we have integrated, but this working is supposed to be shown. You're supposed to show this working. So we got this solution. We are now substituting into our volume expression. Remember here, our volume Vy is equal to 2 pi, the integral of this part, and we integrated that part, and this is what we got. So just going to substitute our solution, which is minus x e to the exponent of minus x minus e to the exponent of minus x, like this. Having our limits, now we are done with the integration, so we can now put back our limits. So that is how we're supposed to have this. All right, we can see that we are having, yes, our formula, this and that, we are done, but the later part on how to integrate, what are you supposed to use? We can see that, all right, there is a need for us to apply by parts. So it differs with another question. Maybe it's a direct integral. You integrate, but this one is not directed to use what? By parts formula. But after that, after integrating, remember, substitute the upper limit and lower limit. So it's going to be 2 pi upper limit minus the lower limit. So on the upper limit, our x is a 1. So you're going to substitute, that's a 1. So it's going to be minus 1, which is minus e to the exponent x. It's minus 1 minus e to the exponent of x, which will be minus 1, like that. Minus x, it's a 0. Guys, any number times 0, that's a 0 on that part. So this will be 0 minus. So that will be a 0 minus e to the exponent of a 0. That's what? That's a 1. So any number to the exponent of a 0, you know that it's what? It's a 1. So we are going to simplify this. We are done, right? So let us try to have this on our calculator. But if you simplify properly, guys, this is what you are going to obtain. This whole part here is going to give us 0.264, something like that, all right? But let us just do it together on our, okay, sorry for that. So let us just do this together here. Okay, so this is it here. Let's open the bracket. We've got minus e. So this is minus e to the exponent of -1. Okay, minus e again, e to the exponent of -1, like this. All right, minus, this will be 0 minus 1, like this. All right. So already here, my calculator, I have fixed this to 3 decimal place. Remember that, shift setup, fix, press 6, then to 3 decimal place, like that. So it rounds off your answers to 3 decimal place. All right. Then we multiply times 2 pi, our answer, because there's a 2 pi outside there. So it's going to be 1,660. So this is 1,6602, 3 decimal places. All right. So this is our volume, which is measured in what? Cubic units. All right, so that is how we could have obtained our volume with respect to y. But this was obtained from the strip of what? Of x. We used the representative strip for x to calculate the volume root about the y. So there I said to use the shell method. All right, then after that, the question on 5.33 is now calculate the volume moment and the about the y-axis. All right, so we need the volume moment about the y-axis. We are told the about the y-axis as well as the distance, all right, of the center of gravity from the y-axis, meaning to say we need x bar from the y-axis, that is the x coordinate. All right, this is a single curve that we are given. What am I trying to say? This curve is not bounded by any other curve. We are given just a single curve. So this is what you do. All right, remember there we want to calculate the moment, the volume moment about the y-axis. All right, so this is what we have from our formula sheet. I want us to check this so that we understand also each other. So on volumes, you've calculated your volume, then you go to the volume moment. All right, so here these are our volume moments here. So they are saying the volume moment about the y, about the y-axis, so we are using this v, the volume moment about the y. So that's the formula that we have. I'm going to explain this. Let me write the formula first, then we talk about this. So from that part, that's 5.33. All right. So from that part, it states that the volume moment about the y-axis is equal to the integral of r dv with our limits a to b. So this is what we had, the volume here that we calculated. Then the question is, the question is, we are worried about the y-axis. So this is volume about the y-axis. So this is what it means. This R here is simply, this is a single, like I said, if it is a single function, you take it represents the representative strip that you are given. It's your representative strip as it is, like what you are given as your strip. It is representative what X values. So the strip here represents the X values, all right? So for a single function, you just take the X as it is, all right? If it is representing Y values, you take the Y as it is. So meaning to say here, we are going to have the formula properly written as the volume moment about Y is equal to the integral of having our limits A to B. These are taken from the X values of the strip. So this will be X. Then dV, I say this, it represents the volume expression that you had. So it's not, guys, be careful. It's not a fixed formula. No, no, no. This one is our fixed formula, this one here. Not to say you're going to have a certain volume moment is equal to, you are supposed to memorize that one. No, the one that you're supposed to memorize is this one. Then you are supposed to know what to do on that formula. So what is that you're supposed to do here on the volume? dV is the volume expression. Before we had this volume, what was our, before the integral, the volume expression dV here, it will be taken from 2 pi. So that will be 2 pi xy. This is what we had from this part dx, so that we integrate to obtain Vy. So dV is the previous part or before the integral sign was there. So we are simply taking 2 pi xy with respect to x, all right? From this one, from that is why it's a continuation, this one. Whatever that it's from that, it's from the previous question. So you take from the previous volume that you had. So meaning to say from the previous question that we had, our dV is the volume expression. We take that, just leave out the integral sign. So that will be 2 pi. So this is 2 pi xy, all right? That is what we had. That, guys, as it was on the volume, all right? So this is 2 pi xy dx. That was what our dV was before we integrated, all right? So this means here we can take out the constants out of the integral, 2 pi. So that is going to be 2 pi, the integral of having our limits A to B. So as you can see here, there is X and there's also X. So X times X, they are for a strip and a strip. So this is same as R squared. So X times X, which is X squared, times Y. I said Y always represents what? Your f of X. So Y, our f of X was what? E to the exponent of X, our function. It's for E to the exponent of, E to the exponent of what? Minus X with respect to X. All right, so here there's no need for us to write A and B. We have to substitute the exact limits for A and B. Remember our A and B from our limits, that was 0 to 1. So that's 0 to 1. So that is the volume moment. That is the volume for Y. So it's not a fixed formula that you say, I have to, no, 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 no. This one, interpret it. If you can interpret this, you're done. All right, so this is what we have. Just like the previous case, we'll see that our volume moment, whatever that we have, that is need to be done in order for us to have the volume moment. We are supposed to integrate this, the integral of this. And as you can see, we are back to again by parts, because the product of x squared again, so this is a by parts. We're going to integrate x squared e to the exponent of from our by parts. So the integral of x squared e to the exponent of x dx is going to give us what? Remember, our formula is not changing, guys. We say this and that is going to give us f of x by gx minus the integral of f of x gx dx at the end. This is what you get from whatever integral that you have there. Remember that. So an f of x being our algebraic function. So you're going to take the algebraic, which is x squared. That's going to be the first derivative from this function here. We need the first derivative, that is 2x. Then g prime x, which is the exponential, and I think we talked about this. So this one, guys, is just a repetition. E to the exponent of minus x dx. We talked about this here. Dx there, we just need a dx, which is e to the exponent of minus x dx. And you said if we integrate this, we're going to have gx, which is e to the exponent of minus x over minus 1, which is, we talked about this, we end up with what? E to the exponent minus e to the exponent of minus x. All right, so taking this into consideration, now our formula, we were supposed to have our integral as f of x by gx. F of x, that is x squared, so it's x squared by gx, which is minus e to the exponent of minus x, like this, minus the integral of the first derivative of x, which is, in this case, we've got what? 2x. So this is 2x times gx, which is our gx, which is the part, minus e to the exponent of minus x dx. Gonna have a dx there. All right. So this is what you're supposed to do. On your simplify, multiply this, you get minus x squared e to the exponent of minus x. Negative and negative here gives us what? A positive. So this will be positive. You can take 2 out, so it will be positive what? Positive 2. We remain, if we take the constant out, we have taken negative out and 2, so that it becomes a positive 2 because there's already a negative there. So you remain inside of this integral with x. And here you remain with e to the exponent of minus x. Remember, you have taken this negative out with respect to x. This is what you're going to remain with. But guys, what is it that we are seeing here? What is it? If you take a closer look, this is why when I'm saying N6, you have to be careful also, because this part here that we are seeing here, if we check properly, this part here, the integral of x e to the exponent of minus x, this part alone, this, all right. If you check, it is the one that we had here as it is here on our integrals. We integrated here e to the, this one, x, e to the exponent of minus x, and this is what we got here. This was our integral from this part. So we are simply taking, instead of us redoing that integral, we have the answer for that integral, all right? We have already integrated this type of an expression, all right? So meaning to say here, we are simply going to substitute. So this will be minus x squared e to the exponent of minus x plus the integral of this. We integrated this before. So we are simply making a what? We are simply making a substitution to say on what we got before. What was that integral of this whole part here as it is, guys? So that was minus x e to the exponent of minus x minus e to the exponent of minus x, like this. All right, so that is our integration plus cost of integration, like said, which is going to be minus x squared e to the exponent of minus x, e to the exponent of minus x2 times minus, that will be a minus 2x e to the exponent of minus x2 times minus here, that will be minus 2 e to the exponent of minus x, like this. So this here is our final integral of what? Of this whole part of the integral of x squared e to the exponent of minus x, which is the one that we needed here. We needed to integrate x squared e to the exponent of minus x, which is exactly this one that we're integrating here by parts. So we are just writing the solution. After that, what is it that we got? So from this integral, this is what we got here, the whole of this part. So this is the one that we are to substitute there. So meaning to say our volume moment with respect to y is going to be 2 pi is already out of the integral. So this will be 2 pi. What we got after integrating this whole part, we got this expression, all right? So this will be minus x squared e to the exponent of minus x minus 2x e to the exponent of minus x minus 2 e to the exponent of minus x, like this, with our limits from 0 to 1. So that was the idea of our question. So you see that here, this was our simply by parts, again, the same application of our by parts, just like the previous question, but all those calculations should be properly presented and shown. All right, so just like the previous case that we had, after all the integrals, we are supposed now to substitute our limits. So that means we're gonna have our volume moment with respect to y, that will be 2 pi, having the limits of x being 1. So that's 1, guys, 1 squared is 1. So this will be minus e to the exponent of minus 1 minus x here, it's 1, so it's minus 2 e to the exponent of minus 1 minus 2 e to the exponent of minus 1 like this. All right, then minus, if x is as 0 here, that will be as 0, 0 squared. So anything multiplied by 0, that's as 0. The same thing here, that's as 0 here. So e to the exponent of a 0 is what? 1. So we are going to be left with a 0 minus minus 2 times 1 is what? It's minus 2 like this. So that is the idea. Or just substitute, guys, as it is on your calculator. Put a 0 there on your calculator. You'll see that you get 1 at the same thing. All right. So just to show that we are moving on together, I want us to simplify properly each and every part. All right. I want us to simplify properly here. We're going to have 2 pi. So if we expand this whole bracket combined together, you're going to get something like 1,606, something like that. That is to show that we are actually moving on together. I mean 0,16, something like that. 0,1606 like that. All right. Then we multiply that number, that whatever that you have, by 2 pi. All right. To 3 decimal place, you're going to get 1,009 units to the exponent of 4. Remember, this is what? Volume moment. Like I said, you can use your calculator to round off to 3 decimal place. That's what you're going to get. But that is not only the part of the question here to calculate the volume or no. The question also goes on. So guys, you have to be careful on your formulas. Use your formula sheet, all right? Everything is there. Then we also need the center of gravity from there, from the y-axis. So from the y-axis, and like I said, it's x, it represents what? X bar. From the y-axis, that's your x bar. So you just need your formula. All right, okay, I reduced a little bit. Okay, like this. So there we just need our formula. If you check from our formula sheet here, from our center of gravity, for the x bar is the volume moment for y over the volume. So you're gonna need the volume moment for y over the volume calculated before. That is how you calculate. So it's a volume moment that you had. All right, so here's a continuation. So here our x bar is gonna be volume moment for y over the volume calculated before. That corresponds to that volume for y, which is 1.009 units to the exponent of 4 over the volume for one that we calculated before, 1,660 units to the exponent of 3. So this one is going to be a u, which is units. So that will be 0,608 to 3 decimal places. All right, so that is our distance. Just like that, just like that. So guys, let us know our formula sheet. We have to understand our formula sheet as much because that is your assistance in exam. Because there's a lot of things that you have to crack in 3 months, in actually 2 months. So try also to understand your formula sheet. Most of the formulas from our N5 is just a continuation, 1 or 2 things that we are having, the shell method, but the rest, most of the things we had them, and also this part of the moments and that. So let's try to revise as much questions as we can, and we shall have as much questions as we can so that we also understand the idea of this topic.